Okay, so this is Algebra 1, Semester 1, Chapter 5.5 and 5.6, Standard Form and Parallel and Perpendicular Lines. So, Standard Form. Up to this point, we've done slope-intercept form, which is y equals mx plus b. We've done point slope, which is y minus y1 equal to m times x minus x1. That's point slope, that's slope-intercept. And now, this section deals with standard form. And standard form is in the equation of ax plus by equals c. And here's the rules that they say, and they don't really say it all, so I'll add on to it a little bit. So ax plus by equals c, where a, b, and c are real numbers, and a and b are both non-zero. Okay, here's the deal. When they say a, b, and c are real numbers, it's a little misleading. So I'll say this: a, b, and c are whole numbers, meaning no fractions, no decimals. No fractions, no decimals. That's number one. Number two, a, in most cases, I haven't seen it where it's not the case, but a is usually positive. It's a positive number. Always. B and C can be either positive or negative. Either positive or negative. Doesn't matter which. So A is positive, and B and C can be either positive or negative. Doesn't matter which. A can be 0, and B can be 0. A actually, yeah, A and B can be 0, but not at the same time. I don't know why they don't say all these things in the definition, but not at the same time. Alright, those usually are the conditions. A, B, and C are all whole numbers, no fractions, no decimals. A is positive. B and C can be either positive or negative. A and B can be 0, but they can't be 0 at the same time. And those are the conditions of standard form. They talk about x-intercept and y-intercept. So let's go back to what a y-intercept is first. So y-intercept. Y-intercept is y when x is 0. y when x is 0. So it's usually in the form of 0y. That's our ordered pair. So if that's what an y-intercept is, then we can conclude that an x-intercept is x when y is 0. X when y is 0, and that's usually in the ordered form, is going to be x 0. So what do these guys represent? This is where the line crosses the x-axis, right, 0y, or the y-axis, and this is where the line crosses the x-axis, x0. So y-intercept, y when x is 0, x-intercept, x when y is 0. And standard form is really good at finding both those intercepts. Okay. So easy way to find the x and y intercept. Super duper easy. They give you the equation here for 1a. They give you 5x. We're not graphing. We're just going to find the intercepts. So 5x minus 6y equals 60. Then want to find the x-intercept. So the x-intercept we'll do 5x minus 6. Now y is 0, right? X when y is 0 equals 60. So then that's 5x equals 60 divided by 5. And that's x equals 12. So then the x-intercept is 12. The y-intercept, remember the y-intercept is y when x is 0. So the x is now 0, and we're looking for y. Divide by negative 6. Don't forget to divide by the negative sign. And we get y is equal to negative 10. So x-intercept, I substituted 0 for y in order to find my x. That goes away, and you're just left with 5x equals 60. Divide both sides by 5, and there you go. X-intercept, y-intercept, x when y is 0. I mean y when x is 0, rather. Substitute 0 for x. That goes away, and you're left with negative 6y equals 60. Divide both sides by negative 6, y equals negative 10. So that's 1a. 1b, we have 3x plus 8y equals 12. So same thing. X-intercept is x when y is 0. So it's going to be 3x plus 8y equals 12. Oops, not 8y. 8 times 0 equals 12. So then that's going to be 3x equals 12 divided by 3 on both sides. X equals 4. For the y-intercept, remember that's y when x is 0, so that's going to be 3 times 0 plus 8y equals 12. So that's going to be 8y equals 12 divided by 8. Y equals, so 12 divided by 8 can be simplified, dividing top and bottom by 4. 12 divided by 4 is 3. 8 divided by 4 is 2. Y equals 3 halves. Yep, that's it. Not bad at all. Horizontal and vertical lines. So, these intercepts are examples of vertical lines. So, if the line is vertical, right, that where it crosses the x-axis, meaning that, and this is in standard form, meaning that y is 0, or rather the coefficient in front of y is 0. So, and you're left with, so let's go back. So standard form, right? Ax plus by equals c. So when we talk about a vertical line, b is 0. So it's going to be in the form of ax plus 0y equals c, which is ax equals c. And then, no, my fault. Also, a equals 1, always. So it's going to be in the form of 1x plus 0y equals c, right? That goes away. I have 1x equals c, and then the 1 goes away, and it's going to be x equals c, right? So this is a vertical line. The vertical line is always going to be the form of x equals c. When we talk about a horizontal line, it switches. B is equal to 1. A is equal to 0. So it's going to be in the form of 0x plus 1y equals c, right? That goes away. That's 0x because it's 0. So it's going to be 1y equals c, and then it's going to be y equals c. So vertical lines are always going to be in the form of x equals something, some number, and then y is always going to be in the form of, for horizontals, y equals something. Okay. We're not going to ask you to graph those, so but just know that vertical is x equals, horizontal is y equals. Transforming into standard form. So remember, for our standard form, ax plus by equals c, we can't have any fractions. And most of the time, vast majority of the time, a is going to be positive. So if we have a situation here where we're trying to convert something and turn it into standard form, and there's a fraction involved, we multiply by the denominator. So here the denominator is 3. So I'm going to multiply the whole entire equation, not just the right side, but the left side, all by 3. So 3 times this whole expression here, 3 times this whole expression here. So that's going to be 3 times y minus 2 equals 3 times negative 1/3 times x plus 6. The whole thing is being multiplied by 3. I do the distributive property here, which is 3y minus 6 equals, this guy goes away, right? And I'm left with negative 1. So negative 1 times x plus 6. And that gives me 3y minus 6 is equal to distributive property negative x minus 6. And then I'm going to well, that sucks. I'm going to add 6 to both sides. That goes, that goes. Then I got 3y equals negative x. And then add x to both sides. And I get 3y plus x equals 0. And then something we didn't discuss, but can C be 0? Yes, C can actually be 0. That's perfectly fine. Just that A and B can't be 0 at the same time. And that's our equation in standard form. Alright. Oh, no, it's not. X has to be in front. X plus 3y equals 0. That's the equation in standard form. Okay. Okay, so that's it. For 5, that's standard form. Parallel and perpendicular lines. So parallel, parallel. I use the symbol, the two parallel lines like that. So when I write parallel, that's what I'm going to use for the word parallel instead of writing that long ass word parallel. Perpendicular has a symbol too. And then for you who will have me next year in geometry, we'll see this a lot because I write it a lot. Perpendicular looks like this. It's like the little, it's like an upside down T. Sometimes I might even put a box here to denote perpendicular. So what does perpendicular mean? What does parallel mean? Well, parallel means that the slopes are equal. So let me write that down here. So parallel parallel lines have slopes that are equal. Alright, so that's parallel lines. Perpendicular lines have slopes. This book calls it opposite reciprocal. I've never heard it called opposite reciprocal before. Slopes. But I mean, it means the same thing. That have slopes that are negative reciprocals of each other. That are negative reciprocals. So what does negative reciprocals mean? If I had a slope of 3, then its perpendicular slope would be negative 1/3. And when I multiply negative 1/3 times positive 3, I'm always going to get a minus 1. So these guys are inverses, right? Opposites, and they're negative inverses. So when I multiply them, they'll always be negative 1. So parallel lines, slopes are equal. Perpendicular lines, slopes are negative reciprocals, opposite reciprocals. When I multiply these guys, I will get negative 1. So so here they give me a situation where they give me an equation, then they give me a point. So the point is negative 3, negative 1, and then the equation is y equals 2x plus 3. The book says they want a scenario where we have a parallel line that passes through this point, but is parallel to this line. So it passes through this point and it's parallel to this line. The way to set this up is to use a point slope form and then convert it into slope intercept form. So remember that point slope is y minus y1 equals m times x minus x1. So what I'm going to do is I'm going to use the slope for this guy. So the slope is going to be 2 because it's parallel. And then I'm going to use negative 3 for my x1 and negative 1 for my x2, right? And when I put them in, I'm going to convert it over into slope intercept. And here's how I'll do it. So I'm going to plug in my numbers. So y minus negative 1 equals 2 times x minus negative 3. Okay? That turns into y plus 1 equals 2 times x plus 3. Y plus 1 equals distributive property 2x minus 3. Alright, at this point, it's almost there. I'm going to subtract the y from both sides. Which gives me 1 equals 2x minus y minus 3. Then I'm going to add 3 to both sides. And that gives me 4 equals 2x minus y. And this is already standard form, but I like my standard form for my variables to be on the left hand side. So I'll just switch these two guys, and it's going to be 2x minus y equals 4. And that's it. That's standard form, right? And remember, standard form is in the equation or in the form of ax plus by equals c. So that fits. That's in standard form. So we started off at point slope form. We substituted the points. We knew that it was a parallel line, so the slopes are the same. And then we used the distributive property after we substituted, and then we move things on both sides so that we can put it in standard form. Perpendicular, we just talked about it. They're negative inverses of each other. Perpendicular lines always form right angles. And what is a right angle? Right angle is two lines that when they intersect form a 90-degree angle. So a 90-degree angle is straight up, straight to left, 90 degrees. You will see that a lot in geometry. Again, the book calls it opposite reciprocals. I call it negative reciprocals. It doesn't matter to me, the same thing. or negative inverses. Alright, so they want us to find out if these guys are perpendicular, parallel, or neither. So the way that we do that is to compare or contrast their slopes. So for 2a, I have y equals 3/4 x plus 7. So this is already in slope-intercept form. And then I have the other line for x minus 3y equals 9. I would have to convert this guy into slope-intercept form. So the way that's going to work, actually I'll do this. I was going to make that blue. So that's 4x minus 3y equals 9. So I'm going to turn it into point slope. So it's going to be our slope intercept. So that's 4x minus 3y equals 9. I'm going to subtract 4x on both sides. That gives me negative 3y equals negative 4x plus 9. Then I'm going to divide both sides by negative 3. Why am I dividing by negative 3? Because I need for it to be in point slope, y always has to be up by itself. And that gives me y equals 4/3 x plus 3. The slope for the first equation is 3/4. The slope in this equation is 4/3. They're not the same. They're not negative reciprocals. Therefore, it's not perpendicular. It's not parallel. It's neither. It's not perpendicular parallel at all. So it's just two different lines. For 2b, we have 6y equals negative x plus 6. And we have y equals negative 1, 6x plus 6. This is already in point slope form. We have the slope here of negative 1, 6. This is in something. I wouldn't even call it standard form. Maybe some version of point slope, but I doubt it. So for this one, we just have to turn it into point slope. Slope intercept. So it's going to be 6y equals negative x plus 6. I'm just going to divide everything by 6 because we want y by itself. Remember, there's a 1 in front of that. X. So that gives me y equals negative 1, 6x plus 1. Both of these two equations are the slopes are the same. They're both negative 6. Therefore, same slope. So these guys are parallel lines. Same slope. Therefore, they're parallel lines. Okay, and then lastly, write an equation that's perpendicular to the other line. So we have an equation. This is 3. It has a point of 1/8. The original equation is y equals 2x plus 1. and they want to find a line that intersects at 1/8 that is perpendicular. So the first step is to find the perpendicular slope. So we know that perpendicular is perpendicular slopes are negative reciprocals. So if we have a slope of 2, then the perpendicular slope is negative 1/2. So our our perpendicular slope rather is negative 1/2. So that's step 1. Step 2, we can use point slope and turn it into slope intercept. So that's y minus y1 equals m times x minus x1, right? And I'm going to substitute. I'm going to substitute 8 for y. I'm going to substitute negative 1/2 for m. And I'm going to substitute 1 for x1. I'm going to use the distributive property here. And that gives me y minus 8 equals negative 1/2 x plus 1/2. I'm going to multiply 8 top and bottom by 2. So y minus 16 over 2 equals negative 1/2 x plus 1/2. The reason why I turned it into a fraction is so I can add or subtract them. I'm going to add 16 halves to both sides. And that gives me y equals negative 1/2 x plus 17 halves. And that is my equation. Y equals negative 1/2 x plus 17 halves. And that is in y-intercept form. Not y, slope-intercept form. Alright, and that's that section. Again, I'm not going to ask you to do any graphing. So all I care about is that you know that parallel slopes are the same, perpendicular slopes are negative reciprocals of each other, and that when you convert slopes to define the parallel or perpendicular equation, the second one, you have to start off at point slope form first, plug in your numbers and your slopes, and then manipulate it such that you turn it into slope intercept form, and then you're done. All right. I'm finished. Hope you have a great rest of your day.